Hello, everybody. Welcome back from Click Talk Engineering Open Lecture Series. My name is Dimitai, and I am doing the Open Lecture Series in mechanics subject. And for those of you who are watching this video for the first time, we are doing Open Lectures series in mechanics 2, student book. The publishers is Pearson Edexcel International A Level. And since we are covering all the theories, most of the problems in this textbook, if you watch and study with our videos closely, I'm very much sure that at the end of this course, you will be able to sit the mechanics 2 subject for international A level. And those of you who are in the university, and of course, this course will prepare you to have a strong foundation on the mechanics subject, which is of course indispensable to further your advanced level subject in your engineering or science and technological track. So please subscribe to our channel, and of course do study with our videos. And today basically we are looking at two things. The first one is when you throw a particle against the pull of the gravity and you want to find out what is the type of motion. And second, you will want to also calculate the speed at any time after you initially release your particle against the gravity. So basically, we are interested in these two things. But before we do it, as usual with our lectures, let's try to have a look at some of the important points that we studied in the previous videos. So basically, we first look at the three types of motion, and those are constant speed, accelerating motion, and decelerating motion. And of course, we also have variable acceleration, but this will be covered in another chapter. So if you look at constant speed motion, or of course this is constant speed or steady speed or uniform velocity. And since the velocity speed is uniform or constant, you will have zero acceleration. And for accelerating motion, the direction of the acceleration is the same as the velocity. So the direction of acceleration is really important because it will be used to determine the type of motion. So if your direction of acceleration is in the direction of motion, so this means the same with the velocity, your object is accelerating, and of course vice versa. And if your object is decelerating, the direction of acceleration is opposite to that of the velocity, or you can, in fact, of course, reverse think. If you know the direction of acceleration, and if it is opposite to that of the velocity, your object is speeding, slowly down or decelerating. And the next topic that we look at is free falling motion. So if you look at free falling motion, the object just falling freely to the ground, and there will be no external forces. And of course, the most important force is air resistance. So you just assume the air resistance is negligible, and of course, this means your object size is small enough, and also it is not windy. Otherwise, you have to calculate the aerodynamic forces or the resistance from the air. In that case, acceleration may be affected by the mass, and you got to evaluate using, of course, the Newton's second law of motion, considering the aerodynamic forces as well. And since air resistance can be neglected, the mass will disappear from both sides of Newton's second law of motion, and there's a reason the effect of mass can be neglected, and the acceleration will be just equals to g. So if you look at the free falling motion, your object is falling freely vertically downwards, of course, to the ground. So this means velocity, we take positive vertically downward here. And we have in the last video proof that the acceleration is in fact just equals to acceleration due to gravity. So which means the acceleration direction is vertically downward. Now the direction of acceleration is just the same as that of the velocity. So this means your object is speeding up or accelerating, and the rate of acceleration is just equals to 9.8 meter per second square. So your motion is constant acceleration, and the acceleration is just equals to g. And of course, this means we can use the formula for finding the speed anytime. based on the constant acceleration motion. So all you just need to do is you just substitute g in place of a. So your speed at any time t can be found by uh, this equation. So v is equal to u plus gt, and of course g is the slope, showing that the increase in the speed with respect to the time. And of course, from the diagram, you can easily see if you release your object, maybe sometimes initial velocity u, or sometimes you can be zero. At for example, it just drops. And after some time, you can calculate v with this equation. When it hits the ground, you can easily see this is kind of the longest time that the object will take. So that is the reason the object will attain maximum higher speed when it hits the ground. So those are the important points. And apart from that, we also look at that since the affair of mass can be neglected, even we have two particles of different masses, but as long as they are at the same height initially, they will just take the same time to the ground. So this means the higher speed when they hit the ground will be just equal. Also, the time taken will be the same, and the speed at anywhere will be the same. But another case is you can have two objects whose initial position is different. Let's say one object is higher than another object, and of course you are very much uh, convinced that the final speed when they hit the ground, the final speed of the object whose initial position is higher than the final speed of the object whose initial position is lower, because higher object take longer time to reach the ground. So those are the most important points, and we just recapitulated for you so that you will have a kind of revision of the important points before we move forward. And today we are looking at the um, motion when you throw your object freely vertically upwards, of course, against the gravity. So, and again, as we said at the beginning of the video, we are interested in finding out the type of motion. So what type of motion basically it is. We want to be able to calculate the speed of velocity at any time t. So, and of course, you from the previous video, you can recall, if we want to determine the type of motion, basically it will be just based on the Newton's second law of motion. So all we need to do is we just substitute all the forces acting on the particle in the Newton's second law of motion, and then based on that we were trying to look at the acceleration, whether it is zero or some value, right? So Newton's second law just states that just F is equal to mass times acceleration. So this means the resultant of all the forces acting on the system will be just equals to mass times acceleration. And in order to find the forces acting on the system, let's try to draw again the free body diagram. So let's say that is the ground. Your object is initially at certain height. So at time t is equal to 0, your object is freely thrown against the gravity with the initial velocity u. Remember, for this type of motion, you always have to add some kinetic energy. Of course, this means the object will attain the initial velocity u or some kinetic energy so that it can goes up against uh, uh, the pull of the gravity. And what we want to do is, at any time t, we are interested to evaluate how much is the velocity at that time. But before we do that, let's go back to determining the type of motion. So if you want to determine the type of motion, all we need to do is just draw the free body diagram and substitute the forces in the Newton's second law of motion. So if you throw your object freely upwards against the gravity, and of course, because we just freely throw, there will be no other external forces. Uh, uh, it, the only forces acting is just the weight of the object, which is just, of course, equals to mg. And again, we have to neglect the air resistance. So that is very obvious here. So air resistance is neglected again. All right. So now what we do is we just substitute all the forces acting on the system in the Newton's second law of motion. So let's try to do it. So the only force, of course, for the sign convention, we will take vertically upward as a positive because the object is going in a positive direction and the direction of motion is positive. So in place of F, since where is it vertically downward, we will just substitute minus W equals to mass times acceleration, and then W is just mg equals to ma here. And now the mass appear on both sides of the equation, so the mass will just cancel out, and you will just get finally the acceleration is just minus g. All right. So based on that, you have a kind of proof that the acceleration in the freely thrown upwards motion is just a equal to minus g. And of course, this means let's try to look at the direction of the acceleration compared with the direction of the velocity. So the velocity particularly downward is taken as a positive because, sorry, upward is taken as a positive because it's going uh, in the direction of the object motion. And the acceleration is vertically downwards. So this means the direction of acceleration is negative. So since the direction of acceleration is opposite to the velocity, we can conclude that the type of motion is in fact constant deceleration. So this means your object is slowing down, and as a result, you will get negative acceleration, right? So we have just determined the type of motion, and before we move to find the speed at any time t, let's try to pick up some of the important points. So when you throw your object freely against the pull of the gravity, you neglect the air resistance, and the effect of mass will cancel uh, uh, from both sides of Newton's second law. The acceleration will be just negative g. So this means it just again to the center of the Earth equals to the acceleration due to gravity, and since the acceleration is opposite to the velocity, your motion is constant acceleration motion. And yes, now let's look at how we find the speed at any time t. Okay, now let's try to find the formula to calculate the final speed. The speed at any time t. So if you look at uh, your object uh, moving freely against the pull of the gravity upwards, the type of motion is constant deceleration. So this means acceleration will be just equals to minus g. Of course, g is 9.8 meter per second square. So this means your acceleration can be in fact just expressed as minus 9.8 meter per second divided by 1 second. What does it mean? So this means within every 1 second time interval, the speed will be reduced by 9.8 meter per second. So the way you're trying to make sense of the negative acceleration is something like that. And since this is constant acceleration, except the acceleration is negative value, so we can just use the formula for finding the speed for the constant acceleration, which is just v is equal to u plus at. And of course, you substitute minus g in place of a, and you will get this expression to calculate the speed at any time t. So your speed at time t will be just v equals to u minus gt. So you have initial velocity u, then your speed will be again reduced depending on the time, and the rate of decrease in the speed is just minus 9.8 meter per second within 1 second. So and now let's try to look at this with the uh, numeric example. So if you look at this diagram, so what we have is your object initially at a certain height from the ground, and at time t equal to 0, the initial velocity will be 29.4 meter per second. Again, your object is thrown against the pull of the gravity by adding some kinetic energy. This can be done by pushing with your hands, like when you play basketball or uh, tennis or something like that. And of course, launching the rock. When you launch the rocket, you add some kinetic energy by giving very large force. So the object will just move against the pull of the gravity by certain initial velocity. So in this example, the initial velocity is u equal to 29.4 meter per second. What we are interested in is finding the speed at any time t. For example, like one time t is equal to 1 second, how much is the speed? One time t is equal to 2 seconds, how much is the speed, and 1 time t equal to 3 seconds, how much is the speed, and so on and so forth. And of course, if you are interested in, you can include the direction of the acceleration, which is just minus g, so it's vertically downwards and toward the center of the earth. Now all you need to do is, of course, you just use this equation. So in this equation we can substitute. So your v will be just initial velocity 29.4 minus 9.8 and time t. So this will be just the equation to get the speed as a function of time, and you can see clearly the speed will be reduced by, again, 9.8 meter per second within 1 second. So let's try to make a table. So this, the first column is the time, the second column is the speed. At time t equal to 0, so you just substitute 0 in this equation, and then we don't have to calculate, in fact. But if you are into mathematics, you just substitute t equal to 0 in this equation, you will get 29.4 meter per second. And t equal to 1 second, you just substitute here again, you will get 29.4 minus 9.8 times 1, so which is just 29.4 minus 9.8, you will get 90.6 meter per second. So in fact, all you just need to do is just subtract 9.8 from 29.4. So subtract 9.8 at every time step, because the rate of decrease in the speed is just 9.8 meter per second within 1 second. So when time t is equal to 2 seconds, you can either substitute t is equal to 2 in this equation, or you will just subtract from the previous time step 9.8. So you will get 99.6 minus 9.8, you will get 9.8. And one time t is equal to 3 seconds, 9.8 minus 9.8, you will get just 0. Right, and now from here you can easily see that at the first time step, the speed difference is in fact minus 9.8. And second time step is also minus 9.8 because the acceleration is constant. And of course, in the third time step, you will also have minus 9.8. So the rate of decrease in the speed, which is the deceleration or the slope of this equation, is just a negative number. And now, based on that, in this example, at time t is equal to 0, your final speed will be just 0. And of course, it's very natural because the object is going against the pull of the gravity, so its kinetic energy will be consumed and transferred into the potential energy. So this means the speed will be reduced as the time progresses, and finally, at a certain time t, the velocity will be 0. So this means the object no longer has the kinetic energy, so kinetic energy will be just 0. And of course, since the speed of kinetic energy is 0, the object does not have any energy to further move upwards against the pull of the gravity. So the object position is at the maximum height, and the object will no longer able to move up. So what happens is the object will just freely fall back to the ground. So so now you are able to calculate the speed of object when it is freely thrown upwards against the pull of the gravity. And you also know that after certain time t, the speed will be 0, and the object will fall freely back to the ground. And of course, for free fall after maximum height, you can calculate using the speed equation that we find out for free falling motion. And of course, you can have uh, you can find the speed both the freely throw upwards motion and free falling motion as well. So this we will do in the next video. And before we say goodbye, I just would like to again make some of the initial points here. Sorry, important points here. So when you throw your object against the pull of the gravity, so sometimes we just would like to call that this is freely throw up motions against the pull of the gravity. And of course, the first important thing is air resistance must be negligible, and the effect of mass again is neglected because the mass will disappear. The mass will appear on both sides of Newton's second law of motion, and then they will just cancel out, and the acceleration is just equals to minus g. And of course, this means every 1 second your speed will be just reduced by 9.8 meter per second, and that is the reason you will have the type of motion is constant deceleration motion, and the equation that you can use to find the speed at any time t is just u minus gt, and you can easily see the speed will be uh, uh, will decrease with the time, and at a certain height the speed will be at a certain time or height the speed will be just zero, and that we call the maximum height of the particle. So the particle uh, cannot further go upwards against the pull of the gravity because it has no energy. Then it will just freely uh, fall back to the ground. So those are the main points of this video. So please study, and of course you can have some of the O-level exam problems that you can refer to. So please practice with this video, and with it, let's just say goodbye, and we'll see you in the next video.